recently. 10 o'clock.
Okay, so let's begin here. So as I said, you're going to be able to subtract vectors and recognize the vector subtraction situation. That's probably key, number one, before you can do the subtraction. Okay? So hopefully you can follow along with me here. So, oh, and you know what? We need clickers. Let's begin. So, subtraction of vectors. What do you think it means? I'll take a wild guess. And remembering that addition means place them tip to tail. If this is vector 1, and this is vector 2, we put them tip to tail. So, any ideas about subtraction? Exact opposite.
Tail to tail.
Tail to tail. There's actually several ways to sort of think about it. Okay? I like your way. That's the way I always start by teaching. Okay? Oh, why have I got all students signed out? I don't know. Okay, so do I have it here? It's right there. You probably learned subtraction probably about, when do they first do subtraction? Well, grade 2 maybe? I have no idea. Right? They probably taught you big number has to come first, right? Why do they do that, Sammy? Why do they say the big number has to come first? So it doesn't, because they don't want to teach negative numbers yet, right? Did teachers lie to you about that?
Yes.
They did. We're a bunch of liars, pants on fire. Teachers do it all the time. We do it in chemistry. We teach about the Bohr model. Big lie. Not how it really works. Okay? It happens all the time. We teach you simple models that are good enough for the building block for the next level. So same thing with subtraction. Okay? Now, subtraction of scalar numbers can be rewritten as addition. You were probably shown something like this, maybe about grade 7 when you got to negative numbers, right? Something like that, right? So something like 10 minus 6 could be rewritten as 10 plus minus 6. It's really, as Joel said, adding the opposite, adding the negative, adding the complete opposite. Okay? That's what regular, everyday, run-of-the-mill, president's choice subtraction is. Adding the negatives. Can we use that idea in vector subtraction? And the answer is yes. The negative of a vector is a vector having the same magnitude, but exactly the opposite direction. Exactly the opposite. Okay, so for example, if vector A is to the right like that, well then negative A is going to be to the left, like that. Exactly the opposite. If vector B is up and to the right like that, well then minus B is down and to the left. Exactly the opposite. I'll pause there. Most people get the visual ones, right? If it's right, then it's left. If it's up to the right, down to the left. We have to go beyond that. We have to deal with numbers, okay? When you're driving and you pull a 180, what does that mean? Spin around, face the other way. Where does the 180 come from, lady? 180 degrees, right? 180 degrees means the opposite. So, if the bearing of vector C is at 0, 1, 0, a bearing of 10, what's the opposite direction? What is it? It's not 315, Martin. I understand what you did there, right? But remember, 10 is going to be like that, right? And 350 would be like that, right? You sort of went like the opposite direction on the, yeah. So what would it be? Pulling a 180 means add 180 degrees, right? Look at your protractor, your circular one, if you have that one, right? 0, 90, 180, 270, right? So 10, bearing 10 is like that, 10 degrees. So the opposite would be 10 degrees there, which is 10 degrees past 180, which is 190. You simply add 180. But what do you do if it's like this, like if it's 300? What do you do, Carter? Subtract 180. So you get 120. So the rule for going the opposite direction is add 180 or subtract 180 to make it work out, right? Like if it's more than 180, then you subtract. You could also just always add 180, but then you'd go past 360, and then you'd have to subtract 360, right? So, yeah. Okay. Those ones are relatively easy. What about south 15 east? What's the exact opposite direction of south 15 east? South 15 east. The opposite's going to be? North 15 west. All you do is just change those to the opposites. It's really pretty simple. Right? Just change. It's not hard.
It is when you're tired.
Okay. So, here's my question. Have you been paying attention?
No.
Let's see. Number one. What is the negative of 10 meters per second east? 10 meters per second east. What is the negative or the opposite? Which one of those do you think is the best answer? Oh, thanks, John. And the answer is yes. B. Now, I saw some people put A, not terribly 100% wrong. Like if it's plus 10, then the opposite is minus 10, right? And 10 east is really plus 10. We use that. So minus 10 meters per second isn't terribly wrong. And minus 10 west, well, that's kind of like a double negative, right? It's negative and west. So likely the best answer is B, but A and D are certainly arguable. Hopefully no one picked C. I don't know how you could get C. Okay. This one I've made a little more challenging. If vector x is 25 kilometers an hour at north 30 east, what is minus x, the opposite? Survey says?
Mr. Brennan, everyone's finished.
Thanks, John. Correct answer is D. Why is it D? North becomes south. 30 remains the same. East becomes west. Right? You flip them. North becomes south. East becomes west. Okay. So far, you guys are doing great, right? All you're doing is you're showing me the opposite, right? Now, we went back to scalar subtraction. It was adding the opposite. So what's vector going to be? Just adding the opposite. That's all it's going to be. So here's the rule. To subtract vectors, find the inverse, find the opposite, find the negative, find the inverse of the vector to be subtracted, and simply add it tip to tail to the other vector. I'll pause there for a second. To subtract vectors, find the inverse of the vector to be subtracted. So you have to identify which one is being subtracted, which one is going to be the negative. Flip it around, and then just do vector addition that we've done the last 2 or 3 days. Here's an example. You guys probably have to put it on the side there somewhere, right? Here's A, here's B. Am I supposed to be clicking here somewhere? No, I'm not. Okay, so I just got to show you, right? So it's A minus B, so I take B and I flip it around. I'm just going to do this. I'm going to clone it and then flip it. Okay, so there's minus B. And then what do? Add them. A, there's minus B, and here's your answer. Now, when you do regular subtraction, like scalar subtraction, number subtraction, when you add them, they're called the sum, and when you subtract them, they're called the? Anybody? It's a pretty ordinary word. The difference? It's called the difference, right? I don't know if there's another word for vector subtraction in vectors. Okay, so I just call it the result. I don't think there's another word. So what did I do? I took A and I added the opposite of B, and that's it. All I did was add one extra step to what you already know. That's all I did, right? Let's do an example, shall we? Is that the same example you have? 10 meters north? Yeah. 15 meters east. What is A minus B?
We don't have.
Let's just do it here. Which is the one we're subtracting? B. How do I know? It says minus B. So I'm going to go A and then minus B, right? So negative B is going to be not 15 meters east. It's going to be 15 meters west. And then we're right back to where we were yesterday, adding, right? So north, 10, 15 west. By the way, west is to the left. Still a few people struggling with that. Are they right angles? Are they perpendicular to each other? They are, which means I can use Pythagoras. I do not need to do scale drawing. R squared is 15 squared plus 10 squared. Now, do I need to put like minus 15 in there? No, for a couple reasons. One, even if I put minus 15 in there and you square it, what's going to happen? It's going to become positive. And the 15 is really just the side of the triangle. Once you get into Pythagoras, we don't care about the direction. Okay, so don't worry about it. It's just going to be 15 squared plus 10 squared. And now I need a calculator. 15 squared plus 10 squared, and then square root 18. The resultant is 18. Now, some of you might even realize that, hey, if I didn't flip this around, like if I just went 10 and 15, what would be my resultant? What would be the size? Well, it would be exactly the same, wouldn't it, right? So this really has no bearing, pun intended, no bearing on the, like whether it's subtraction or not. You're still going to get this, right? It's still going to be 18. But what really matters is the direction. There was a couple people yesterday I saw on the quiz that had their theta at the wrong spot. It's always where? Where you start. Always where you start. Always.
I don't even think they put it in on there.
Always where you start. Okay, so opposite and adjacent. Theta inverse tan of opposite over adjacent is going to be 15 over 10. Make sure your calculator's in degrees. I get 56. And that's going to be north 56 west. Sarah, what did I do different today from yesterday? What's the only thing that's different? But when you say subtraction, what do you mean? Like, which one of those steps? What step did I have to do today that I didn't have to do the other day? Yeah, exactly. That initial flip, right? That's all that's different here, right? So it seems hard, but just think of it as, oh, it's just one extra step. It's that flip thing, right? No big deal. Ah, now, oh, you don't have that, do you? Okay, let's do this. Back to thinking here. I'll let you read that, and then we'll see how it goes. Okay, so we've got vector A is 5 meters north, 5 meters per second north. Vector B is 4 meters per second west. Which diagram best shows A minus B? Is it A, is it B, is it C? Correct answer? C. There goes your 100%. Why is it C? 5 meters north. We're doing A minus B, so which one are we flipping? We're flipping B, so we're going to go north. And B is 4 meters per second west, so it becomes east, which is to the right. So it's going to be like that. This one here. This one is A plus B, isn't it? This one's A plus B, and here we flipped the wrong one, right? So this one would really be B minus A. What a wonderful multiple choice question. Now, how do you know when to subtract. That's the second thing we all learned today, right? We learned how to subtract, but how do you know when to subtract? Well, the first one is easy. It says subtract. It says subtract. Okay, so I got A, I got B. A. Oh, that's not minus B, is it? Oh, I'll have to flip it instead. I say I'll have to flip it. Flip it. Flip it now. Very disappointing in myself. That's not minus B, is it? Okay. How do you know it says subtract? It says the negative sign there. That's the easy one, right? And there's going to be some of those. Okay, now, here's the hard one. Okay? If you've sort of lost track of things a little bit here, if you sort of lost focus, refocus, we're getting close here. It implies subtraction because it asks for the wind or plane speed or current or boat speed. And I was thinking about vector subtraction this morning, because that's what I always do, think about what's coming up on the day. And I realized this slide was coming up, and I thought, you know what? I haven't really talked about plane and wind and boat and current yet, have I? Okay, so I need to do that, and I need to add this to this lesson. Okay? When you've got real world, if you're the navigator on a plane, the resultant is whatever the plane speed is plus whatever the wind speed, right? Like if I'm flying a plane like this, Martin, right, but the wind's blowing that way, I end up over here, right? The resultant is the plane plus the wind. The overall result vector is the plane speed plus the wind speed, right? Well, what am I supposed to put in there, I wonder? Okay? And the other one that's quite common is boats in currents, right? So if I'm driving my boat across the river, but the river pushes me that way, I end up over here, right? The resultant is the boat speed plus the current speed. Hopefully you left a little bit of room in there because I just remembered what's supposed to go in there. This is where I'm going to lose you. I can tell already. I'm losing people. I'm worried. Okay, so if I rearrange this equation for P, if I rearrange this for P, solve for P, isolate P, the plus W has to go to the other side, it becomes negative W. So the plane speed is going to be R minus W, isn't it? The plane speed is the resultant speed minus the wind speed. And conversely, how do I isolate for W? The P goes the other side, so when you're solving for wind, well, that's going to equal resultant minus plane, isn't it? And you can see that they become vector subtraction, exactly same. So really, what I'm saying is it implies subtraction because it asks for the wind or the plane or the current or the boat. It doesn't ask for the resultant, it asks for one of, we call them the components, one of the pieces of the puzzle, either the plane or the wind or the current or the boat. It's implying subtraction. Okay, down here, boat speed is going to be what? What formula am I going to put in here? R minus C, and this one's going to be R minus B. Again, vector subtraction. Nod. Say, yeah, I get that. RBC, man. Okay, here's the practice one. Are you getting worried? Here's the practice one. Okay, try the first one. I'll give you about 5 minutes. Try the first one. I'll do the answer, and then we'll do the second practice one together, and then I'll give you a chance to work on stuff. Okay?
B scale.
R squared equals 10 squared plus 35 squared. R becomes, it's going to be 10 squared plus 35 squared square root 36.4, which is only a little bit more than 35, right? Because 35 is so much bigger than 10. Find theta. Remember, theta is where you start. Guys, I need you to listen now. Leighton, even if you know what you're doing, just let other people listen. Theta, opposite over adjacent. Opposite here is 10. Tan minus 1, opposite over adjacent, 35. $15.9. And that would be north, well, we'll say 16 west, right? Okay, how would I mark something like this? Well, again, 1 mark for the angle, 1 mark for that. I don't need a scale here, but I need to see the flip. So 1 mark, I'm looking for the flip on the direction on that diagram, right? If you didn't flip it, would you still get 36.4? You would. Would you still get 16? Yeah, you would. It would just be 10 over 35 in the opposite direction, right? So a full mark there is for that flip. I must see the flip. The flip says I know what subtraction is. Okay. This one is hard. This is the hardest one you're going to see. Spend 5 minutes and actually try, you guys. Even if you get it wrong, that's fine. Give it a whirl. If you get it wrong, then you can identify your mistakes. If you don't try, then you can't identify a mistake. Here's the hint. A plane needs to end up with a resultant velocity of 100 kilometers an hour at east 30 north. The wind speed is 25. What direction in the wind should the plane take? So what is my resultant of the situation? It's 100 at east 30 north. The wind speed is 25 kilometers an hour at north 15 west. What direction and speed should the plane take? You are solving for the plane. The resultant of a plane in wind is the plane plus the wind. And so the plane is the resultant minus the wind. Right? That's what we just did. We just talked about that right here. Plane speed is resultant minus wind. This is exactly what navigators of planes need to do. They need to go there. They need to know they're flying from Winnipeg to Minneapolis in X amount of time. They know the distance. They know, right? They know when they got to be there. They know the resultant velocity. They check the weather. This is the wind speed. Which direction should they fly? They need to know the plane. How fast should we fly and what direction? It's exactly what a navigator will do. Now you need to get out of your bed, please, so you can hear me. So it's going to be resultant minus wind. So it's going to be minus wind, so this becomes, I'll put it in red, 25, not north, but south, 15 east. So you're taking this vector and you're adding it to that one with a scale diagram. Those people that are unsure, I need you to try, okay? It's much better to make a mistake and fix it than just copy it down. Copying it down, you're not learning it, right? You got to go out there and you got to be willing to make mistakes. It's the only way to learn. Okay, so a plane, I'm going to go right back to the start. Plane needs to end up with a resultant velocity of 100 kilometers an hour at east 30 north. That is my R. The wind speed is 25 kilometers an hour at north 15 west. That's my wind. What direction and speed should the plane take? Okay? If there was no wind, the plane would just take off at 100 kilometers an hour and go at east 30 north. But there is a wind. The wind is blowing them off course, so they have to angle into the wind, right? So my overall plane speed, because R equals plane plus W, solve for plane, wind goes to the other side, resultant minus wind, right? Resultant minus wind is my plane speed. So which one do I flip? I flip my wind. Only the wind. That's the one we're subtracting. Right? So I flipped it. Instead of 25 north, 15 west, it becomes 25 not north. It becomes south. And instead of west, it becomes east. And now it just becomes what?
Plain old vector addition, just like you guys did the last couple days. No different. The only step, Sarah pointed this out half an hour ago, the only step that's different is making that flip. That's the only thing that's different. So I'm going to go east, 100 at east, 30 north. So I draw my reference line, east, and then I'm going to go, I need a scale, right? 1 centimeter equals, I've got 125, so what did you go? Did you go, probably not 5. Did you go 10? 20? I would probably go 10. Okay? I would go 10 kilometers an hour. Whose tea kettle is boiling? Okay? If you go 25, then it's going to be really small. Don't do that. You want it to be a decent size. The smaller it is, the more chance you're going to have an error. So I'm going to go 25. Seriously, stop. 1 centimeter equals 10, so I got to go 100, so I'm going to go 10 centimeters long, right, at east 30 north. Something like that, right? Where's my 30 degrees? This is 30 right here, right? How long is this? 10 centimeters. 10 times 10 is the 100. Okay, nod. Yes, I get that. That is label. What should I label that with? That's your R. Right? Okay, then we're adding minus W. W is 25 at south, 15 east. Draw a reference line. South, 15 east. Right there. Go south. And then you got to go 15 degrees towards east. Right? It's 25 divided by 10 is 2.5, so it's going to be 15. It's going to be like about 2.5 centimeters, kind of like that. Right? Label that one with a minus W. Let me finish. And so from where you started to where you ended is my answer. I'll put it with a dash line. And what would you label that? That would be P, exactly. That would be the plane speed. If I want to go, if here's Winnipeg, that's a bad example. Okay, no, we'll go, that's Winnipeg, and no, it's the opposite direction. I'm trying to think of two cities that are like that. We'll go Brandon and Winnipeg. They're kind of close like that. Okay, if I want to go from Brandon to Winnipeg, if there's no wind, I'm just going to fly right to there. But if the wind is blowing me, sorry, not that way. The wind is blowing us at north 15 west. If the wind is going this way, right? If I fly straight to Winnipeg, I'm going to get blown off course. I have to fly into the wind. Right? I got to fly this way and let the wind do what? Push me there. Right? The wind is pushing me this way. So I have to fly into the wind. Resultant minus wind. Does that make sense? Now, how long is this? I don't know. And in fact, at this point, I don't even care about the answers. Okay? Did I do an actual scale on there? I didn't get out the ruler. I didn't get out the protractor. I don't care about the answer. I care about the work. If you get that far and you're off, you're likely going to get 3 out of 4. That's how little I care about the answer. I care about the work. Now, someone had it pretty close. Who thinks they got it right? Catherine, what's your answer? I'm going to go to yours. Go ahead. Come on. Catherine.
Maybe. I don't know.
Carter, what's your answer? 99 kilometers an hour. East 15 north. That looks pretty close to me. It's probably 90. Actually, it would have to be 100.
It's probably not.
It would probably have to be more than 100, I think. Catherine, what did you get? Did you get more than 100? What'd you get? No? It's likely more than 100, but that angle is about right.
Well, at least they're not half of it.
Okay? How do you feel about that? Okay? How do you feel? Jessica? No? Maybe? Okay.
what I did was, on the back here, okay, I'm going to give you a little bit of time now. On the back, there are 4 practice questions. There are solutions at that link right there. If you have a scanner on your phone, a QR code on your phone or your iPod or whatever device you have, you can scan it. It goes right to, and when I say solutions, I don't mean answers. I mean like detailed, like that. How to do it. Okay? Get a scanner. Okay? They're also available in the red binder as well. I've talked enough. Enough talking. Okay? You guys practice. We'll revisit this on Monday.